Hey guys, Mr. Middleton here. Continuing on with our logic chapter in geometry, we are going into reasoning with algebra. At the end of this video, you should be able to apply the properties of equality and congruence to prove problems involving algebra. And you should be able to justify each step of a proof. Reset this sheet. Okay. Alright, this is going to be our introduction to proofs. And a proof is a mathematical argument that lays out step by step how to get from a starting point, oftentimes a hypothesis, to a ending point, oftentimes the conclusion. Alright. Proofs are typically shown, at least in this class, as two-column proofs. I think that's how you spell it. But can also be flow proofs or even paragraph proofs. They all show the same information, so usually if you can do one, you can do the others. Usually if you can do a two-column proof, you can do the others pretty easily. Alright. Each step in the proof must be justified. Okay, the justification of each step uses previously learned definitions, postulates, theorems, properties, and more. This is why you must know these things as they are taught. Okay, so we'll go through some of these properties. I'll list them out. You'll notice that most of them say if A equals B or if A is congruent to B. Because that's our starting point. These sides have to be the same. So the addition property of equality, all these are properties of equality, and then these are congruents. You can tell by the different signs. All this says is A plus C equals B plus C. Subtraction, A minus C equals B minus C. Multiplication, division, A over C equals B over C. Alright, so all this is saying is if I add, subtract, multiply, divide the same number from both equal sides, then it should still be equal, right? As long as C is not 0 in division. The reflexive property pretty simply says A equals A. Okay, something equals itself. You use that a lot more than you would think, but it's true. Symmetric property, we'll say if A is congruent to B, then B is congruent to A. Transitive property, if A equals B and B equals C, then I say equals, I messed up. If A is congruent to B and B is congruent to C, then A is congruent to C. And substitution is if A equals B, then B can replace A in any expression, or A can replace B in any expression. And finally, the distributive property, you just distribute AB plus AC. Alright, so went through this list pretty quickly. It's not really difficult to know these, but you do need to spend some time looking at those so that you're able to recall those without too much mental strain, I guess. Alright, let's look at some examples of using these properties, and we'll go from there. So, if x plus 4 equals 3x, then 4 equals 2x. What happened? Okay, you have to ask yourself, what happened from this step to this step? Well, it looks to me as if we subtracted x from both sides. Okay, and so that's the subtraction property. Subtraction property. Okay. If m equals 2n minus 5 and m plus n equals 16, then, now this is telling us to use substitution, We can substitute and say, okay, well, instead of saying m plus n equals 16, we can say 2n minus 5 plus n equals 16. And so notice that now we substituted, instead of using m, we used 2n minus 5. Okay, and this is something that we would do in order to solve this problem. If P is congruent to Q, angle Q, and angle Q is congruent to angle R, and angle R is congruent to angle S, then what can we say? Well, then we could say the transitive property that angle P is congruent to angle S. Okay, so notice that they never connected P and S, but we should be able to see that angle P and angle S are congruent to each other, since they're both congruent to R, which is congruent to Q, and Q is congruent to P. Number 4, we have 2 times h plus 7 over 8 equals 3. Then 2h plus 7 equals 24. Well, what happened? How did these things change? Well, the most obvious is there's a fraction here and there's not a fraction here. How did they get rid of the fraction? Well, it seems that they multiplied both sides by 8. Okay, and so that reasoning that would go with that step is the multiplication property of equality. Okay, we're able to do that because of the multiplication property of equality. That's justifying your steps. You're justifying how can you say this and this. Okay, so you can think of this as every step in a proof you need to say, if somebody's saying, why can you say that? You say, if 2 times h plus 7 over 8 equals 3, then 2 times h plus 7 equals 24. How can you say that? Well, because of the multiplication property of equality. Okay, so that's basically answering why for every step. Prepares you for having a 3-year-old later in life, or high school students with homework. Alright, here we go. So we have this equation, 5x minus 12 equals 32 plus x. And they want us to justify each step. They've already solved the problem for us, so it's not solving the problem that we have to focus on. It's saying why for each step. So 5x minus 12 equals 32 plus x. We went to the next step. What happened? Well, it looks like, and this might be helpful for you to do, we subtracted x from both sides. Okay, and so that's the subtraction property of equality. Subtraction property. Okay, with that, I don't like to abbreviate sub because it could be substitution. So I usually say sub t because that's subtraction. Okay, next step, what happened? Well, now it looks that we added 12 to both sides. And so that's the addition property of equality. And you could just say addition. I understand that you're meaning property of equality. What did we do next? We went from 4x to x and 44 to 11. Looks like we divided both sides by 4, so we can say the division property of equality. Okay, P prop. Okay. Alright, so again, shouldn't be anything that's too difficult there. You just understanding what you're doing to get from the other step. It kind of helps you to think out loud. Okay. So here we go. We're looking at a different example now. It's more of a geometry example, one that you would see more as a geometry example. And so in this problem, it's given to us that measure of angle ABD is 107 degrees, and the measure of angle ABC is 66 degrees. We want to prove this. So what this is saying, the given is like the hypothesis, and what we're trying to find is the conclusion. So in other words, this is saying if the measure of angle ABD equals 107 degrees, then the measure of angle ABC is 66 degrees. Okay, so basically us proving our hypothesis. Connecting our conclusion, proving our conclusion from our hypothesis. So the measure of angle ABC plus the measure of angle CBD equals the measure of angle ABD. ABC plus CBD equals ABD. Why can we say that? Okay, remember that is the angle addition postulate. Angle addition postulate. Okay. From there, what should we do? We'll kind of get a clue here. We should use substitution. And that's what we'll use. What is measure of angle ABC? Well, ABC is 4x plus 12. Or sorry, 4x plus 2. Okay, so that's the measure of angle ABC. Then I'm going to add to that the measure of CBD, which is 3x minus 7, equals ABD, which they told us was 107 degrees. So we're just substituting all the stuff that we know. Alright. Now, on this left side, we have 7x minus 5 equals 107. What did we do on this left side? We put together our like terms. Okay. Now, some people will say add like terms, and that's fine. If you say add like terms, I really don't like that one as much. I would say simplify. Okay. So I'd rather you say simplify than add like terms, but I'm okay with both. All right. From there, the next step should probably be into solving for x. So we'll add 5 to both sides. 7x equals 112. Okay, notice I'm doing this here, and then I'm justifying it here. That's our addition property. What's the next thing I should do? The next thing I should do is I should divide by 7. X would equal 16. And that's our division property. Okay. And now that we know that x is 16, I'm going to plug this back in. Me plugging 16 in is substitution. Okay, so I'm plugging 16 in. I found that x was 16. I'm plugging it back in to angle ABC because that's what I'm trying to prove. And then simplify. Simplify. Okay. Okay, notice how the last step is what we're trying to prove. This will always be the case. All they asked us to prove this thing. So if we say that, we're done. And until we say that, we need to do more. Okay, so the last step will always be what we're trying to prove. But notice that the last justification isn't prove. It's not, I did this because you told me to prove it. Okay, I was able to say this because I simplified the previous step. Okay. Also notice that with the steps 3 and 7, I'm not doing anything to both sides of the equation. For the addition, property of equality, division, substitution, or subtraction, all those things, I'm doing something to both sides of the equation. Okay, but when we're just putting numbers together, it's simplification. Okay. Okay, let's look at one last example. Suppose A, B, and C are collinear with B between A and C. Okay, I'm going to draw a diagram because I like those. It makes me not have to think as much. So A, B, and C are collinear with B between A and C. Somewhere between them. So, got that? Down. They told us that AB is 2x plus 4. And BC is 15 minus x. And AC equals 21. Alright, so from here what we're going to do, and again they kind of gave us a hint by giving us a justification for what we should do. We're going to set this up, the segment addition postulate. Remember that says that if we have two segments that add up to a whole line, the sum is the whole line. So I'm going to say, okay, well, I know that AB plus BC equals AC. From there, notice that all the numbers that correspond go in. That is substitution. Subs. Alright, from there I should probably add all my like terms together. So I'd have x plus 19 equals 21. That's just simplifying. And then I get x equals 2 because I subtract 19 from both sides. Okay, so reasoning through why our answers are as they are is the name of this game. Hopefully you're able to remember, you're able to apply some of the equality and congruence properties, and you're able to justify each step of your process in solving a problem. All right, see ya. Have a good one.